Hi, I'm Ed Escudero, representing the local section of the American Chemical Society for National Chemistry Week. We hope you're going to be able to experiment with a chemist. In this case, we would like to show you a reaction that was actually developed by two chemistry teachers in San Francisco in the mid-70s. The reaction itself was thought to be impossible, but it's going to be working with three what appears to be colorless liquids. We're going to mix them together, and something that has been found amazing, this little device is known as a magnetic stirrer. There is a stirring, or there is a magnet that is motorized and spins, and I have a small, it looks like a pill, magnet that's covered in Teflon that will also spin. As we mix the chemicals together, I'm going to begin the mixer. No reaction appears to be taking place. Initially, the reaction went from colorless to blue, and most reactions start and then finish, but this one somehow goes back to the colorless and goes back to the blue. And this was thought to be impossible for the longest time, because how can something finish and then back up and start again? In chemical terms, this is known as an oscillating clock reaction, in that we can actually time how long it takes to go from a colorless to a colored solution. What I really like about it, as complex a reaction as this is, it was actually developed by the two chemistry teachers in the San Francisco area who were playing with a simple clock reaction that only goes from colorless and then turns to the blue-black. The reaction itself will probably go on for 15 to 20 minutes. The chemicals that are in there, one of them will eventually be used up, and at that point the reaction will no longer oscillate or go from the colorless to the blue. The yellow that you see forming is actually an iodine, and there is starch in the solution, and if one places iodine on starch, the starch color turns blue-black. If you go shopping with your parents, you may notice that if they give the clerk a $20 bill, they may pick out a pen and rub the pen across the money. If the color turns black, that means it's a counterfeit bill, because the pen has iodine in it and paper has starch. Actual paper money in the U.S. is actually made of a linen, and there is no starch at all in the United States currency.